Have you ever gazed up at the night sky, filled with wonder about the vastness of the universe? We humans have always questioned our place in the cosmos. Where did we come from? Are we alone? And what is this reality we find ourselves in? Now imagine for a moment that everything you see, feel, and experience is not quite what it seems. What if our reality is actually a sophisticated computer simulation, indistinguishable from the real thing? This is the mind-bending premise of the simulation hypothesis. This idea, once relegated to the realm of science fiction, has gained traction in recent years. Philosophers, physicists, and even tech giants like Elon Musk have pondered its implications. Could we be living in a digital world, our lives orchestrated by lines of code? Let's dive into this fascinating concept and explore the possibility that we are all just characters in a grand, cosmic simulation. Imagine playing a realistic video game. The graphics are so advanced, the characters so lifelike that you forget you're staring at a screen. The simulation hypothesis takes this concept a step further. It suggests that our universe and everything in it, including us, could be a simulation running on some incredibly powerful computer. Think of it like this: our current computers can create incredibly detailed simulations, from realistic weather patterns to complex human interactions. As technology advances, these simulations become more and more sophisticated, blurring the line between the virtual and the real. Now, imagine a civilization far more advanced than our own, capable of creating simulations indistinguishable from reality. They could create countless of these simulated universes, each with its own unique laws of physics and history. From their perspective, these simulations would be like video games. But to us, the simulated beings within them, they would be our reality. One of the most compelling arguments for the simulation hypothesis comes from philosopher Nick Bostrom. His ideas have sparked intense debates and discussions in both academic and popular circles, challenging our understanding of reality itself. In his 2003 paper, Are You Living in a Computer Simulation?, Bostrom presents a thought experiment now known as Bostrom's trilemma. This paper has become a cornerstone in the field of simulation theory, often cited and discussed by scholars and enthusiasts alike. He argues that at least one of the following propositions must be true, and these propositions form the crux of his argument, each with profound implications for our understanding of existence. 1. The human species is very likely to go extinct before reaching a post-human stage. This suggests that our technological advancements may lead us to a point of self-destruction, preventing us from ever achieving the capability to create highly realistic simulations. This means we'll likely wipe ourselves out before achieving the technological capability to create realistic simulations. The idea here is that our own progress could be our downfall, a sobering thought that adds a layer of urgency to our current technological and environmental challenges. To any post-human civilization is extremely unlikely to run a significant number of simulations of their evolutionary history or variations thereof. This proposition suggests that even if we do reach a post-human stage, the interest or ethical considerations might deter us from creating such simulations. In other words, even if we reach a point where we can create such simulations, we'll choose not to, perhaps for ethical or practical reasons. The ethical implications of creating conscious beings within a simulation could be too great, leading future civilizations to avoid this path. 3. We are almost certainly living in a computer simulation. This is the most provocative of Bostrom's propositions, suggesting that if advanced civilizations do create simulations, the sheer number of simulated realities would far outnumber the single base reality. If we accept that it's possible to create such simulations and that future civilizations might be inclined to do so, then it becomes statistically more likely that we are living in a simulation than in base reality. This idea challenges our very perception of what is real, making us question the nature of our existence. Bostrom's trilemma doesn't prove we are living in a simulation, but it does suggest that it's a distinct possibility, one that we should seriously consider. The implications of this hypothesis are vast, touching on philosophy, technology, ethics, and even our day-to-day lives. Whether or not we are living in a simulation, the questions raised by Bostrom's work encourage us to think deeply about the nature of reality and our place within it. Section 4, Clues from the Fabric of Reality. While the simulation hypothesis is a fascinating thought experiment, is there any evidence to support it? This hypothesis suggests that our reality might be an artificial construct, much like a highly advanced video game or a sophisticated computer simulation. But how can we begin to find evidence for such a profound idea? Some intriguing clues hint at the possibility that our universe might be digital in nature. These clues come from various fields of science and technology, each offering a unique perspective on the nature of our reality. One piece of evidence comes from the realm of physics. Physicists have long marveled at the elegance and simplicity of the mathematical equations that describe the laws of the universe. These equations are not just abstract concepts, they are the very language of the cosmos. The laws of physics, which govern everything in the universe, can be expressed as mathematical equations. These equations describe the behavior of particles, the forces of nature, and the fabric of space-time itself. They are precise, consistent, and universal. These equations, in turn, can be translated into lines of code, just like the software that runs your computer. This raises an intriguing question. If the universe operates according to mathematical laws, could it be that these laws are actually a form of code written by an advanced intelligence? Could it be that the fundamental building blocks of our universe are not particles and energy, but bits of information? In a digital universe, everything we perceive as physical reality could be the result of complex computations, much like the pixels on a computer screen. Furthermore, the strange and counterintuitive world of quantum mechanics offers another intriguing clue. Quantum mechanics is the branch of physics that deals with the behavior of particles at the smallest scales, and it reveals a reality that is far stranger than anything we experience in our everyday lives. Quantum phenomena like superposition and entanglement suggest that reality is not as fixed and deterministic as we once thought. In superposition, particles can exist in multiple states at once, and in entanglement, particles can be instantaneously connected across vast distances. Instead, it seems to be probabilistic and interconnected in ways that defy our everyday intuition. These phenomena challenge our understanding of space, time, and causality, and they hint at a deeper underlying structure to reality that we are only beginning to understand. Finally, some proponents of the simulation hypothesis point to anecdotal evidence like the Mandela effect. This phenomenon describes instances where large groups of people share a false memory, such as the spelling of a name or the details of a historical event. This phenomenon describes instances where large groups of people share a false memory, such as the spelling of a name or the details of a historical event. These shared false memories are perplexing and difficult to explain through conventional means. Could these shared false memories be glitches in the simulation? If our reality is indeed a simulation, then occasional errors or anomalies might manifest as these strange shared experiences. While the evidence is far from conclusive, it opens up fascinating possibilities for the nature of our existence. Section 5, but what if it's just our imagination? Of course, the simulation hypothesis is not without its critics. This idea, which suggests that our reality might be an artificial simulation, has sparked intense debates across various fields, from science to philosophy. Skeptics argue that it's impossible to prove or disprove the existence of a simulation, making it an untestable and therefore unscientific idea. They emphasize that for a hypothesis to be scientific, it must be falsifiable, meaning there should be a way to test and potentially disprove it. They point out that the evidence presented so far is circumstantial at best. For instance, the idea that our universe's physical laws can be expressed mathematically is intriguing, but it doesn't necessarily imply that these laws are the result of computer code. The fact that the laws of physics can be expressed as code doesn't necessarily mean they are code. Mathematics is a language we use to describe the universe, but it doesn't mean the universe itself is a mathematical construct. And while quantum mechanics is undeniably strange, it doesn't automatically point to a simulated reality. Quantum phenomena, such as entanglement and superposition, challenge our understanding of reality, but they don't provide concrete evidence of a simulation. As for the Mandela effect, it could be explained by psychological phenomena like false memory or confabulation. Our brains are not perfect recorders of information, and memory can be influenced by various factors, leading to collective misremembering. Ultimately, the simulation hypothesis remains a philosophical thought experiment. It invites us to question the nature of reality and our perceptions, but it doesn't provide empirical evidence that can be tested and verified. It's a fun and thought-provoking idea to consider, but it's important to remember that it's not a scientific theory in the traditional sense. Engaging with this hypothesis can stimulate our imagination and lead to interesting discussions, but it should be approached with a critical mind. Even if we can't definitively prove or disprove the simulation hypothesis, exploring its implications can lead us to fascinating insights about the nature of reality, consciousness, and our place in the universe. It encourages us to think deeply about the fundamental questions of existence and to appreciate the mysteries that still elude our understanding. Whether or not we live in a simulation, the journey of exploring such profound questions enriches our knowledge and broadens our perspective. It reminds us that the quest for understanding is as important as the answers we seek.